Welcome back. This is our second class session. Today we're going to cover Chapter 1, Isometric Views and Orthographic Projections. Now, even though I'm calling this Chapter 1, this is where I'm deviating slightly from the textbook. The first 3 weeks I'll deviate slightly from the textbook. And one of the reasons is because some of you may not have your textbook yet or don't have AutoCAD installed in your personal computer or don't have access to AutoCAD yet. And we also have students that are adding the class in the next week or two. So I decided to take isometric views from Chapter 5 and turn it into a Chapter 1 assignment. And orthographic projections, which is actually covered in Chapter 3. And I decided to call this Chapter 1. So once again, if you want to learn more about isometric views, it's in your textbook. It is covered in Chapter 5 and how to sketch isometric views by hand, and also in Chapter 6 on how to create isometric views in AutoCAD. Orthographic projections, it's covered in Chapter 3 and on. So we're going to be constantly going over orthographic projections. All right, so let's go on to the next slide. Okay, so what is an isometric view? So here on the upper right corner, we have an isometric view. Think of it as a bird's eye view, but again, don't call that at work or in front of your boss. This is an isometric view. Here we have the front view. So typically your front view is the view with the most information. Okay, the one that shows the most details. So just imagine you're standing in front of a building. And this is giving us a lot of detail, a lot of information, and we'll call that the front view. Okay, so now for the right side view. How do we get this right side view? So imagine you're standing in front of the building and you go around the building, right? Basically turning 90 degrees, right angle. And now you're looking at the building from this side. So this is the right side view. Okay, so you can see this edge here, this object line or visible line. You can see it right there. This top line represents this line, and so on. Now, dashed lines. Dashed lines are referred to as hidden lines. So what are these two hidden lines or dashed lines representing? Well, if we were standing over here on the right-hand side, we would not be able to see this circular hole that goes all the way through. So just imagine you're Superman and you turn on your X-ray vision, and now you'll be able to see that circular hole that goes all the way through the part. Now from the front view, we can obviously see the circle representing the hole that goes all the way through. So if we're standing back in the front view, we're in front of the building, we can see the hole. But if we go around the side, we cannot see it. So we represent it with dashed lines. So this is the diameter of the hole. So if the hole is let's say 1 inch in diameter, then this would be a 1 inch offset, this line from this one. Okay, so now let's go back to, so once again, we're on the right side view, come back to the front, go around the building, come back to the front view. And now to see the top view, imagine you can fly over the top like Superman, fly over the top and look straight down, and you would get this top view. Okay, so once again, from the front, stand in front of the building, and just like Superman, go up, fly upward, go inward, and look straight down, and this is what you would get. Okay, so the top view, this edge here is represented with this line here, this object visible line. This line here is this one right there in the center. And then this edge on the right represents this edge. Okay, so once again, we cannot see the hole, just like as in the right side view, we cannot see the hole if we're flying over the top. So we represent the hole with these dashed lines. They're called hidden lines. And always note that they line up with the quadrants of the circle. Just like on the right side view, I did not mention this earlier, but here we go. We have the dashed lines lining up with the top quadrant of the hole and the bottom quadrant of the hole. Now, if you ever have a solid line on top of a hidden line on one of your views, so if you ever have, once again, a solid line overlapping a hidden line, the solid line wins because we can actually see it, and we actually draw the object lines thicker than the hidden lines. Okay, and we'll talk more about the alphabet of lines, the line types, and the line thicknesses. All right, so let's go on to the next slide. Okay, so in this class, we're only going to be covering third angle projection. Okay, so here are some examples of third angle projection. Okay, so imagine we're looking at Jack's mugshot, right? So if you're giving instructions to Jack, okay, face the camera, Jack. Okay, that's the front view. Once again, here we have our isometric view. Okay, so if we're standing here in this area, so imagine Jack is a large building. We're standing here, looking straight into Jack's eyes, right? We're going to get this front view. Okay, so again, this is Jack's mugshot. Stare straight into the camera. Okay, Jack, now we need you to turn to your right and step back a few, take 2 steps back, and there's the right side view. Okay, so here's the right side view. Even though we're looking at Jack's left side, this is considered the right side view. Okay, so once again, imagine you're standing in front of the building and you go around at a right angle and then look in, and this is the view you get. Okay, so now we tell Jack, okay, face the camera again. So we come back to the front view. So this is our reference view, and we project it horizontally to create our right side view. Now we're going to project vertically from our reference view, our front view, to create our top view. Okay, so once again, tell Jack, okay, Jack, we want you to face downward. Face downward, look at your toes or your shoes, and then jump up in the air 2 feet. And take the snapshot, take a picture, and you get the top view. Okay, so this is referred to as third angle projection. Okay, and here are some other examples of third angle projection. Here we have a calculator, project. So once again, the front view is always the view with the most information, the most features. Features are details, in this case buttons, it can be holes, pockets, round corners, etc. Okay, and here are some more examples. All right, so let's go on to the next slide. Okay, so let's talk about isometric views. Now in the past, even as early as 10, 12 years ago, when I first started teaching the class, we were still drawing isometric views in our drafting classes. I'm pretty sure in the architecture department, they still draw them by hand. We have gotten away from drawing isometric views, and the reason is because, well, we first used to do it by hand before CAD was very common, before AutoCAD was a very common software decades ago. So we used to create isometric views in AutoCAD and by hand, but then the 3D software is a lot more powerful, a lot more affordable. It's parametric, meaning it's smart modeling. So we've gotten away from doing isometric views. Okay, so we're not going to spend a lot of time in isometric views. Again, this is covered in Chapter 5 pictorials, where they show you how to create an isometric view. I will include links at the bottom for those of you that want to see what it was like back in the good old days, or how the architecture department draws their isometric views. Okay, so you typically start with the box. It's a rectangular box. It doesn't necessarily have to be squared. Think of a rectangular prism. Okay, and we're going to use 30-degree angles to draw our box. So imagine you're making this custom fit box for your part. Imagine like a glove to a hand. Okay, so for example, if you were asked to create an isometric view of this drawing, so you have your front view, top view, side view. Okay, so in the good old days when we were doing this by hand or using AutoCAD, we would start with the box. Okay, so here we have our box, and we would use if we were doing this by hand, we would use our mechanical drafting tools. So when I first took drafting back in the good old days, we had to draw everything by hand before we were allowed to go on to AutoCAD 2D. Okay, so these are the instruments that we use. So using a T-square and triangles. So here we have a 45 triangle, and we also have a 30, 60, 90 triangle. Okay, so we would take our T-square, line it up with our table. So this is our T-square. If we go back, T-square, right? So this to draw horizontal lines. And we can also rotate it 90 degrees so we can draw vertical lines. Okay, so here we have the T-square to draw horizontal lines. And again, we could rotate it and place it on this top edge, but we would typically just use a triangle to draw vertical lines. Okay, so this is a 30, 90, 60 degree triangle. Okay, so we would draw our box. So this is at a 30 degree angle. Then you would flip the triangle to draw this line. Okay, let's go back to this line. So you line up your T-square with the table, edge of the table. Line up your triangle with the T-square. Draw your line. And then you can slide it up to draw this line. To draw that line. Draw this line. Then you would flip it to draw this line, that line, and this line. And we can use this edge to draw our vertical lines. Okay, so this is the old school way of creating a box. Now, again, even 10, 15 years ago, we were still doing this in class by hand, but we've gotten away from using drafting tools. Architecture department still uses their tools. And I'll come back to these plastic drawing templates. All right, so once again, if your boss or your CAD instructor or drafting instructor asks you to draw this, draw it in isometric view of these views. Okay, start with the box. So again, whatever the height of the part is, this would be the height. The length, okay, so the length. If the length was, let's say, 2 inches, then you would draw a line 2 inches. Then we have the depth, okay, the depth of the part. Let's say it was 2.5, then you would draw a line at 2.5 inches in length using your scale or ruler. Okay, so you would draw a rectangular box. Just makes it easier when you draw a box, and typically you would draw with very light lines. Very light lines, because you're going to go back and erase any evidence that you cheated by using a box. Okay, then you start drawing the part. Okay, so here we have the front view if you're standing on this side. And we have the side view. And you start adding details, right? Start adding details. And once you're close to completing the isometric view, you would darken the lines and erase any evidence of the box. Okay, so once again, if you want to learn more about how to create isometric views, you can go into chapter 5 of your textbook. For our assignment for isometric views, we're not going to spend a lot of time on isometric views. So for isometric views, we're only going to spend one assignment on isometric views. So your first handout 1A. Okay, so you are to take the image on the left and duplicate it on the right. If you want to draw a box around it first, again, imagine making a custom-made box, perfect size for this part. And you can also use the grid to draw the part. I don't want you to spend an hour per problem. I think 5-10 minutes per problem is enough. There's 8 problems total. Okay, so you can either print this out. So I will send this attachment through Canvas and also through email. Okay, so draw the lines, count the grid, and draw an isometric view. And if you don't have a straight edge, a triangle, or a ruler, it's okay if your lines are crooked. I don't have an issue with it. If you want to draw it by hand, or maybe you want to do it on your computer, maybe you have a software like Paint or Draw, where you can draw it using line commands or just a pen on your computer. to draw the isometric view. I'm not going to take off points if it's messy or if the lines are crooked. This is just to get get you to get an idea what isometric views are. Okay, so now areas where I will take points off is where you forget lines. Seems to always be the small lines that students forget. They'll draw the long lines, and sometimes they'll forget the little lines. So if you are missing a line, then I will take points off. Another good example is, for example, this line right here. So those are the first lines I look for, the little lines. Students seem to forget it. If you do miss a line, I will take points off. Okay, so this is a 25-point assignment. All right, so now even though we don't cover, we don't go really into it on isometric views, the reason I do want you to just sketch a few isometric views is because when we get together, you know, our instructors here at the college, when we get together and talk with professionals, whether they're architectural engineers or architects or mechanical engineers or aerospace, we get a lot of input from them. And one of the biggest complaints about young drafters or young engineers, and I'm including myself when I make this criticism, is a lot of young engineers or young drafters nowadays don't know how to sketch an idea or an isometric view. So sometimes you have to sketch something on paper, an idea, or maybe you need to draw it up on a whiteboard in a conference room in front of other engineers or drafters or designers, and you want to be able to sketch an idea so that others can follow your concept. Okay, so that's one of the complaints is, yeah, you do need students to be able to sketch an idea, whether it's an isometric view or a front, top, and side view. Okay, so, and again, I'm included as part of that criticism. When I talk about young drafters and engineers, you need to know how to sketch an idea by hand or on the board. Okay, so once again, this is in your textbook, Chapter 5. Now, Chapter 6 will be drawing isometric views in AutoCAD. We don't cover that chapter, but I may turn it into an extra credit assignment, most likely in the second half of the semester. Okay. Now, one thing I did forget to mention, coming back to these templates. So when we were drawing using mechanical pencils or pencils, we would use these templates to draw perfect circles. We also use French curves. In some areas, you need to draw some curvature, and you would use part of the French curve to accurately draw your curves and not do it by freehand. Okay, and we also have templates with ellipses. So why we would use a template with ellipses? Well, this template is specifically made for isometric views. Okay, so we would use these ellipses to draw our holes. Okay, so if we go back to the handout. Okay, so to draw this hole, we would draw a center line. Okay, we would draw a center line, and then we would use our template to draw the hole. If you're looking straight through the axis of the hole, it's going to look circular, right? Same with this one. If you're looking at this partial circle, if you're looking straight down the axis, it's going to look circular. But when you rotate the object, it's no longer going to look circular. It's going to look elliptical. Just take a soda can, look at the top of the soda can. It's going to look circular, right? Obviously, most soda cans are cylindrical. But if you start rotating it away from you, the top is going to look elliptical. Okay, so using these center lines, we would line up our template. So we would pick out the correct diameter. And then that center line I showed you earlier, we would line up these little dashes with our center line to correctly orient our ellipse. Okay, in this case, our hole to draw it out. Okay, so once again, we will use these templates to draw these. Even though they're circular on the object, from this perspective, it's going to look elliptical. Okay, all right, so let's move on to the next slide. Here's another example of a pictorial. This is not exactly an isometric view because this is not at a 30-degree angle. Okay, there's other forms of pictorials. There's isometric views, and this is covered in your textbook, chapter 5, and trimetric and dimetric views. I'm not sure if I'm using the right terminology, but it's covered in your textbook if you're more interested in creating pictorials. Okay, so let's go back to orthographic projection. So we're going to keep hitting on this throughout the whole semester. Okay, so once again, we talked about Jack. Jack got arrested, yeah, I guess got caught stealing some Whoppers from Burger King or something, right? So once again, here's Jack's mugshot, front view. So if we wanted to get a left side view, we would tell Jack, okay, Jack, face the camera, turn to your left and take 2 steps back. And we would get the left side view. Okay, face the camera again, turn to your right, take 2 steps back, and we get the right side view. Now to get the rear view, so from this position we would tell Jack, okay, turn to your right again and take 2 steps to the side. Then we would get the rear view. This rear view can be on this side, it can be on that side, right? It can also be here at the bottom. You just have to rotate it 180 degrees. Okay, so if you want the bottom view, tell Jack to look straight up and then bend your knees, go downward 2 feet, and this would be the bottom view. Okay, another way to think of it is, think of a tetherball, right? Attach the chain or the rope to the nose of Jack. Okay, you're standing in front of the pole. I should say the pole is between you and Jack, and you can watch somebody else hit Jack and swing Jack around the pole. Okay, so this would be the front view. Okay, if you want the right side view, you would tell your friend to hit Jack and have Jack rotate clockwise. So if Jack rotates 90 degrees around the pole and you're standing out here, you're going to see the right side view. If Jack is hit counterclockwise after 90 degrees, you're going to get the left side view. Okay, if you want the top view, you just tell your buddy to hit Jack straight up. So Jack would rotate 90 degrees upward, go vertical, and you would get the top view, and so on. Okay, so this is third angle projection. This is what we're using in class. Here in America, we like to use third angle projection, but be aware that most other countries like to use first angle. So there are some companies here in the US that will use first angle. So let's take a look at first angle. First angle is a little different, right? In this case, you would tie Jack. If Jack had a ponytail, you would attach the rope or the chain to the back of Jack's head and rotate. So here's the front view, right? Rotate 90 degrees. You get this left side view, right? And rotate in the opposite direction and you get this view, and so on. Okay, another way of, so again, this is first angle projection. Be aware of it. There are drawings out there that do have first angle projection. Later on, when we talk about complete drawings with title blocks and borders, typically in the bottom right corner, it should tell you if first angle projection is being used or third angle. Okay, let's go back to third angle projection. Another way of looking at this is imagine, for third angle projection, imagine placing Jack's head inside of a cereal bowl, for example, and the back of the head is always sliding inside the bowl. So later on, I'll give you an example of third angle projection using a bowl. So if the back of the head is always touching the bowl and you rotate it inside the bowl, you would get your views. Okay. For first angle projection, which we're not using in this class, you would flip the bowl upside down. So now you face the bowl downward on the table, and you would place Jack's head, the back of it, on the bowl on the outside and rotate on the outside of the bowl, and these are the views you would get. Okay, so once again, we're not using first angle. Okay, so another way to describe orthographic projections. In this case, we're not going to use a custom-made box for the perfect fit. Here we're intentionally using a larger box. So imagine you take your object and you place it inside of a box. So again, we're going to still cover orthographic projections. So another way is by placing the part in a glass box. And if the part was able to break through the glass and leave a perfect impression, so if you're standing here and the part flies through this front wall, this is the image you would get, right? So, or if you're standing over here in front of the building, this is the image you would get. If you're standing over here on the right-hand side and the part broke through the glass, right, it could fly across and break through. This is the impression it would leave on the glass. Or to say if it breaks through, this is the cutout we're going to get on the glass. And so on. If it breaks through the top, goes straight up, this is the cutout you would get through the glass. Okay, and so on. Okay. Okay, so you can see that surface A, here's surface A, surface B. Now, even though this is sloping downward, in the top view, it's going to look flat. That's one of the things I forgot to mention on one of the earlier on one of these earlier slides. Going back to the second slide, even though this is sloping downward, when we fly over the top, imagine like flying over the houses when you're arriving to the LA airport. You fly over the houses, the roofs don't seem to be sloping downward, even though they are. So even though this is sloping downward, it actually looks flat. Okay, you can see here it's sloping downward, but from the top view, it's going to look horizontal. All right, so let's go back. Okay, so even though surface B is sloping downward, when you create your top view, it's going to look flat. It's going to look horizontal. All right, so this gives me a chance to introduce your next assignment. For your next assignment for today, so our second assignment and last assignment for this session. So this is also from your textbook. By the way, this is in the back of chapter 3. I think it's page 349 and 351 for the second problem. Okay, so for your second handout, you're going to be filling in the bubbles. I did deviate slightly from the actual page in your textbook. So you're going to fill in the balloons, right? So this surface here is B. So if you look at the isometric view, here's B, right? That's surface B. So you're going to fill in the balloons with the correct letters, and some of the letters will repeat. So once again, here's the top view. If you're looking straight down, this is the front view, front. And then we have the right side view. If you're standing on this side, this is the view you get. Okay, so go ahead and fill in the balloons with the correct letter. You are going to use some of the letters more than once. Okay. All right, so once you take this box, let's go back to the glass box method. Then you're going to open it. So you're going to hold on to this surface and you're going to unfold it just like a cardboard box. Okay, so you hold on to your front view, you identify your front view, and then you unfold the glass box to get your orthographic projections. Okay, so you have your front view, right side view, rear view, come back to the front, top view, back to the front, bottom view, right, and the left side view. Okay, so once you flatten out the box, this is what you get. And there's a cool little visual on the internet. So here's what you're doing. You are opening the glass box, just to imagine it's cardboard, and this will give you your front view and your projections. Okay, your top projection, bottom projection, right side, left side, and the rear. Okay. All right, so once again, hidden lines, dashed lines, these are lines that you cannot see from this perspective. So we draw them. I think I mislabeled this. This is the rear view. So looking at the rear view, we're not going to be able to see this edge, for example. If you're standing behind the glass box, we're not going to be able to see this edge. So we draw it with hidden dash lines, right? These are hidden lines, and we use dash lines to represent them with. And we can't see this opening. So see this opening here? If you're standing in the back, you can't see this opening. So we represent it with the dash lines, right? Hidden lines. And I did mislabel this slide. This is the rear view, not the front view. Okay, so now so we've been talking about third angle projection. For first angle, let's go back. For first angle, they do things a little different. First angle projection, which we don't cover in this class, we're only going to cover third angle. They actually project the views in the opposite direction. So this view would go back here. This right side view would go the other side, and so on. So the views get projected in the opposite direction. And when you open the glass box, you would actually hold on to this panel and open the glass with respect to this fixed panel. Okay, so we do not cover first angle. Okay, let's move on. Okay, so here's another example of unfolding the box. Okay, now, once again, the front view is typically the view that gives you the most information. Now, how many views do you need? It depends on how many details, how many features are on the part. Sometimes a single view is more than enough. So if we go back to the templates, so if you were making a drawing of this drawing template, for example, all you need is one view. Because if you look at it from the side, it's just a thin edge. So you would just draw one view and then call out the thickness of the material, whether it's a 1/16 of an inch, 1/8 of an inch, for example. Okay, so something like this, one view is more than enough because it's a flat piece. Okay, so sometimes a front, top, and right side view is good enough to show all the details and all the features in the part, whether it's a hole, a wall, a chamfer. When you cut a corner at an angle, that's called a chamfer. Okay, so if there's additional features, then you do need to add more views. You try and show the minimum amount of views. If 3 views is good enough, then leave it at 3 views. Don't start adding a 4th and 5th view because it's cool, or your boss is going to tell you only provide the minimum amount of information to get the part made. So once again, typically 3 views is good enough. You can go with the front, top, and side. Or you can go with the front, top, and left side. Okay. All right, so we'll talk more about this as we go through the semester. Okay, another example of unfolding the box. So in this case, this is the front view if you're standing here looking in. Okay, and once you unfold it, flatten it out, you have all your projection views based off of the front view. Again, third angle projection. Okay, now let's take a look at a bicycle. Now, even though we know that this is the front of the bike, this view has more information. Okay, so this view we're going to call the front view. Okay, there's a lot more information in this view, so we'll call this the front, even though it's not the front of the bicycle. And then project 90 degrees. Okay, so again, just like Jack, turn to your right and step back 2 steps, and that's your right side view. Come back to the front, face the camera. Okay, turn to your left and take 2 steps back, and so on. Okay, so another example of third angle projection. Same thing with the vehicle. Even though this is not the front of the vehicle, this has the most information, so you're going to call this the front view. And typically the front view, because of our eyes, right? Our eyes are set up horizontally. When you go to a movie theater, you know, the screen is wider than it is taller, right? Because of the position of our eyes are set up, lined up horizontally. Okay, so this will be our front view. And swing it 90 degrees to create your right side view, and so on for your left and top views. Again, third angle projection. Another example of a third angle projection drawing. Another example of a third angle projection in case you're into VWs. And here's an example of first angle projection. Okay, so first angle projection, you go in the opposite direction. So again, we're not going to cover first angle projection because it'll cause a lot of confusion, but just be aware that it's out there. Okay, so if you're ever looking at a drawing that for some reason doesn't make sense to you, most likely it's in first angle projection. I remember my first drafting job 15, 16 years ago. The estimator planner, the one that plans out how the part is going to be made and estimates the cost. We're looking at this drawing of an I-beam for an aircraft. So commercial aircraft, like those large aircraft you see in the airport, whether it's a Boeing or an Airbus, a 787 or an Airbus 350. So this company was taking this aircraft, passenger aircraft, removing the seats and turning it into a cargo plane, you know, something you see for like a UPS or FedEx. So in order to be able to handle all the weight of the cargo, you have to remove the beams, the floor beams, similar to what you see in a house, the floor beams or joists, and replace them with something stiffer and stronger to get so they can handle the weight. Yeah, so we're looking at this drawing of a beam for this aircraft, this cargo aircraft, and it didn't make sense to us. The views just didn't make sense to us, and the reason it was because we didn't realize we were looking at a first angle projection drawing. And again, this was a drawing from another country. Okay, so don't be surprised when you see drawings from like Europe or Asia or South America where they use first angle projection. And again, you have to look at the title. So here in the title, it'll tell you what type of projection is being used. Okay, so this is the end of the lecture. And in our next class session, we'll continue drawing orthographic projections by hand. And by the fourth class session, we will jump onto AutoCAD. So be ready on our fourth session. I'm going to give you a lot of homework. I'm going to throw a lot of AutoCAD drawings to you so you can start using the AutoCAD software. End of lecture.